All right, so rocks are formed of minerals. So if it has one or more minerals, we call it a rock and no longer call it a mineral. There are three main types of rocks. There's igneous, sedimentary, and metamorphic. I'm sure you've probably seen the rock cycle at some point in time. But igneous rocks are formed from the cooling of magma. Um, and we have Oh, yeah, they call it plutonic or volcanic. Okay, so we can call this intrusive and extrusive, which is what the more technical terms would be. Um, Plutonic or the intrusive rocks form if the magma cools inside the Earth. And when that happens, it cools very, very slowly, and the crystals in the rock have time to really grow. And so you can actually see, so here you've got probably some quartz and some feldspar, and I'm going to get some like biotite in there that you can see. This is a granite here. Or they can be extrusive or volcanic, which means that the magma cools outside, like on top of the Earth's crust on the surface. And when that happens, the crystals don't have time to form so nice and pretty. They just kind of get frozen as little itty bitty tiny specks put together, if you will. And so here is a picture of a volcanic rock where you don't have the crystals forming. And you can also see these little like dents in here are actually little holes where the gas from the lava has escaped, and that's very common in the extrusives or the volcanics. Also, glass forms that way too because it just like freezes. It's almost like a frozen liquid um, coming out, and so that's where you get like obsidian is technically a glass. Um, so you also have felsic and mafic. So felsic are more silicate rich and light in color, and mafic magmas are silicate poor, so they're darker in color. And so this is like your granites are going to be felsic, and then a lot of your like if you go to Hawaii, a lot of those volcanoes are going to be more mafic. Sedimentary rock is formed from sediments that have been lithified. So sediments are weathered from other rock types through wind, water, ice, things like that. Then they're deposited somewhere, let's say the bottom of like a lake. And then through time, they're buried deeper and deeper and deeper, and they're compacted more and more and more. They're cemented together. Cementation is when a mineral precipitates out of solution and kind of glues all those pieces together. So the process of compaction and cementation lithifies these grains or these sediments together, and then you get a sedimentary rock. There are two types of sedimentary rocks. There are clastic and chemical. Chemical is from precipitation, more or less. Um, and then clastic is when it's come from other rock types, which is pretty much what I just described. The whole process of a clastic is something breaking down from like a granite, breaking down smaller and smaller into sand, and then being turned into sandstone. Chemical sedimentary rocks would be like your halite, where it's precipitating out of solution. So here are some examples of clastic rocks. We have sandstone, shale, and a conglomerate. Really, the main difference here is grain size. Big pebble-sized grains, sand grains, and then clay grains. Um, yes. And then we've got the chemical sedimentary rocks, so the halite, the calcite, the gypsum, these are all precipitates. And then they throw in biochemical as well, which is like your limestone and your chalk. So pretty much anything that has a lot of organisms in it. So here are some different limestones. Metamorphic rocks are when another rock type, even a metamorphic rock type, can be remetamorphosed. Um, It's exposed to a lot of temperature and or pressure, and it changes so much that it actually becomes like an entirely different rock. Here are two examples. So this this is quartzite. Quartzite is metamorphosed sandstone, and marble is metamorphosed limestone. So if I just go back, if you read, I'm sure you've seen a marble table or something. This is not, and that comes from this. And so it is a very, very different rock type. Um, and so how does that happen? Recrystallization can occur. So they get heated up so much that they can kind of start growing again, kind of like how I was talking about the plutonic rocks, how it's hot for a long time so the crystals can grow. So you're reheating things, which allows a little bit more mobilization of the atoms and any kind of fluid in the rock. And so they can actually kind of dissolve or grow or do both, and that changes things. And then the pressure can also fold it, compact it, foliate it, which I think we're going to talk about on another slide. And then there are different types of metamorphism. There's contact and regional. Contact is when it's right next to a magma chamber, and directly in contact with lava within near a volcano. Um, and there's regional metamorphism, which is really either from deep burial or building mountain processes. Um, Most commonly from mountain building processes. Um, and you just get a lot of pressure. Okay, so here's the foliation. So here's an example of foliation. So we have slate. So slate is already metamorphosed shale. And then we have slate. And then slate, if you continue its metamorphism, and this is usually through the regional like mountain building process. So as you get more and more pressure, and as things get deeper and deeper, and then this can turn into schist, and then this can turn into gneiss. And so how does this happen? If you think of like toothpicks and you put pressure on a toothpick, that toothpick, if you go from tip to tip and start squeezing it, the toothpick is going to rotate and then eventually like lie flat. Like if you stand it on a table and start pushing that toothpick, it's going to eventually lie flat. And so that's what happens with the minerals in these rocks under all that pressure is they kind of start to lie flat compared to whatever direction the pressure is coming from. And that causes this foliation. And then this doesn't have a picture of a rock cycle on it, and I was afraid to like, just find one on Google for copyright purposes. But I'm sure you've seen it, and the book does have an image of the rock cycle in it. Um, and their point here is that it's like not as there's no order. It doesn't always go like igneous, sedimentary, metamorphic. Like a metamorphic rock can be metamorphosed into a different metamorphic rock. A sedimentary rock can be re-weathered and then returned into a sedimentary rock. It can turn into a metamorphic. It can turn to an igneous. It's just constantly changing. And that is it for rocks and minerals.